So welcome back. This is the second presentation from CSCS. Nick is from the HPC operations group. I am from another group. That's why we are doing two presentations. And I'm at the user engagement and support group. We do installation and support for scientific applications and libraries. So while Nick's group is doing more tasks related to the hardware level installations, and we are more in contact with the users for their applications. So the idea of this talk, this is a very preliminary work. I started in CSCS in last January, and I was asked to look into this direction. So that's why it's called CSCS Roadmap. I'm not going to explain the tools and the things in detail. I'm going just to present our tests and the directions we are planning to take. And the idea for me is to share the notes, to share the experience, to find collaboration, because I hope that other people are looking at the same directions. So I'm not going to give a working solution that is very nice and working. Everyone is satisfied, because this is just, let's say, a prototype. And then if I can have some feedback, it would be very nice, and then we can discuss about doing cooperation. I know that people from Lausanne also are already interested on doing the same things, and they already have contacted us. So this is the outline. First, I will be very short in the background, because we have already had lots of talks on the subject. So I just give a couple of slides on the two main issues we have, and we want to solve it. Then I will switch to the automatic building tools for HPC that I also try to be very fast, since Pablo and Martin, they have already covered most of the things that we were also looking. Then I will move to the continuous validation part. So one thing is automatic building, as Nick said, and the other thing is the continuous validations and integration that we are looking. And then I will show three use cases that we have already working, and some of them we are still working on. So the demo, I will just show the workflow of one of these use cases. I'm not doing a demo because it could take too long. So this is the thing that we saw today many times, people explaining that the evolution of the requirements have changed so much that now the users, they have, instead of having a simple set of libraries that they were building on their own in the past, now they have a huge amount of requirements, and then often they cannot build on their own, so we have to help them for building that. And the complexity of handling all these different versions of different software for different users, it's becoming a real headache for the HPC systems. So our goals, the first one is to minimize the maintenance overhead by applying automatic building of software, because right now most of the software we build at our group are built by hand, so make, install by hand, no automatic scripts. We have some documentations, but we don't have automatic mechanisms, as Pablo showed before this morning. So when we have an upgrade, every member of our group has to take a look on his application and be sure that it is working and compiling on the new system or on the upgraded system. So it's lots of manual work each time we have an upgrade. So the other goal is to provide a uniform set of libraries and applications in all of our systems. Right now, when a user asks for one application or one library, we install it in one system, and often these users, they move from one system to another, and then they ask again the same tool in another system, and then we are manually installed. And so this is a lot of overhead that we could avoid. So we also want to improve, I want to call it quality of support by adopting the continuous validation and integration techniques. So we install the applications, runtime, and we are not testing it continuously. So every time we do an upgrade in a library, we don't know if the applications are still working. So we want to know if the applications are working without manually running tests every time we do an upgrade. So we want to provide that. Also, another wish that Thomas, our director, mentioned that he wants us to provide to the user a platform for continuous integrations. That means that the users who are often just developing and running scientific software in our systems, they could also have tools to support the testing and to improve the quality. So it's already used in the industry. This is very common, and we want to, let's say, to incentivize the users, the scientific users, to also use the software engineering techniques also for the scientific software. So the challenges for the CSCS are clearly, the first one I could spot is the scale. What's different from other centers that we see here is that we have many systems and many users and applications. And every time I see that we have an upgrade and we see the list of applications, sometimes we have some legacy applications we believe that are not used anymore, but actually, well, if we don't compile in the new system, the next day we have tickets and we see that users are actually using it. So it's really hard to change things and remove features in a center like CSCS because we have many users and very different types of users. We have power users and users that are also just running applications and changing input files. So they are not developers. They don't care about the version of GCC behind. So we have to make them happy, both of them, both kind of users. So the other challenge is to implement a consistent, not to say a standard procedures within teams and also across large teams. Here, it's clear that people, when we say, okay, easy build is very nice. Some people, they are very open, they are keen, they go, they try it, and they use it. But this is not very often. People coming from other backgrounds that are not from computer science, usually they are not so open to new techniques for automatic things because the first thing they say, this is more work for me because the first time you implement you use an automatic building systems, you have to redo everything. So this is extra work. The first reaction is just to try to ignore and continue to work in the same way. So I see that until you don't force them, they are not going to move if it's not a decision that it goes from another level in the hierarchy. So this is the challenge I see just inside our team. So the other challenge it would be to work and have the same methodologies also in other teams and also across other sites. This would be the best thing to have a common way of working. So we don't have any, for the moment, we don't have comparison with Nick's group. So we don't do, even if Nick's is now using Makefiles, this is very good because we could use, for example, with EasyBuild, we can deploy any application that it is using Makefiles. So this is good. It would be nice to work together. So this is a few examples of existing applications. I'm not going to list on details. I would just mention that they lack the isolations. We install packages with YAM, DEB, RPM, and so on. We cannot install several versions of the same software. So for our cases in scientific computing, we need several versions of the same software, and these tools, they provide limited support. Also, they don't provide usually support for reproducing the same build and the same set of installation of packages in other systems. So it's not really adapted for our needs. And also we use module systems as every modern or not so modern HPC center, so some of them also lack that. The last thing is the fact of using manual and interactive steps means that it is very error prone. So even if I have a recipe, I do it. If I give to someone else, probably the results could be different. So I selected 3 tools just for listing. We didn't try all of them. I just downloaded, looked at the web page, and read some papers. So the first one is Smithy from Oak Ridge, and it is written on Ruby, and it is a very simple framework that's everything. When you have a build, it's inside one file, so you can understand what it's doing in the build just by looking one file. And the bad part, let's say, it's that it's very complicated. You don't have a high-level interface and a config file for specifying your build. It's just like a programming. So you are programming is like doing a shell. It would be the same as having a tool written in shell. In my point of view, they don't have anything to make it look easier, and so the last thing that I have to mention is the lack of community. As other people said today, they build for Oak Ridge and then it's used in Oak Ridge. They have it available on the website, but we don't see other people using. The next one, it's more or less in the same category, as they also implemented a tool from scratch to do the builds, and it is Python-based. And this time, for this one, they have a high-level interface for specifying your builds. So it's one thing that it's quite nice is that you can specify your dependencies without putting the versions. So you can have a simple, let's say, base file for specifying your build, and then if you want and you have problems with the versions, you can use on the command line. You can add the versions, or you can write another configuration file to specify the version. So you can pin to a version or not. So this gives flexibility in the sense that you don't need one configuration file for each version. So the last one that is, in our case, we said is the winner, the one we choose. That's why you have more details. We decided to use EasyBuild, mostly because of the growing community that also Pablo mentioned this morning. Actually, Pablo was the example that convinced us to use it because he was not from the community. He was not from a main developer. He used EasyBuild, and then he became from the community, and now we can see that he's contributing back, and so it means that from our point of view, the tool is very flexible and it's not restricted to one side. So from this experience, we decided to look further, and then we look as more in detail. So this, I think most of you know already. It is divided in 2 levels. You can use easy config files it has an easy syntax to specify your build, or you can use the easy blocks for more complex builds. And one thing, just to say, I'm not selling the software. I'm here selling the software, and I will also say some things, some problems we had in for adopting this software. Since we use Cray machines that have already some some libraries that are supported by Cray, so we pay for the support. EasyBuild it doesn't work out of the box with this kind of environment. It is very good if you build from scratch a new toolchain. That means you have only GCC from the system, and then you take a toolchain that is already available on EasyBuild, and then you rebuild everything. It works out of the box. It's just great. Then, if you have a set of libraries that are already optimized for your system, and you will also pay for the support, and then you need to build a new toolchain, and this is a more complicated procedure. So, from the other side, since they were also EasyBuild team, they were also interested in providing support to Cray system. This is a good thing that we open an account for them in our systems, and they provided in a few days, they provided a new toolchain. So this is very, for us, it had a very positive feedback. Since then, they released a new version of EasyBuild that has already Cray support and it was tested in a few applications, so we need to test more. Okay, so this is just a comparison of all of the three software packages, but the main reason I have to highlight that it was really the fact of having a community, and that we also would be able to share the recipes after we have it running, and then we can share across other Cray sites and also non-Cray sites, because we also have non-Cray systems. For this one I didn't say, but for non-Cray systems, EasyBuild is already working out of the box. So I think I stressed a little bit the part of the Cray system, but the non-Cray systems, EasyBuild is already working just in a few days of testing, and we had already we are answering user tickets with EasyBuild. Okay, so the current status, it's already working as I said, in the Linux clusters, non-Cray, and then we have some packages that are working in the Cray system. Usually, now that we have the toolchain working, it's just a matter of using some flags from EasyBuild to use the current, to use the existing config files for other toolchains. It's just a matter of adding a flag for EasyBuild. So we try the Cray toolchain with the existing easy config files for other toolchains, and this is very good because we can use all the recipes that are already tested in another system, and usually they work. Sometimes we have just to change a few flags or add some parameter, and then we have a working configuration file that we can reproduce and repeat. So this was the EasyBuild part for automatic building. I'm going to switch to continuous integration, and I'll try to explain our idea of integrating both things, automatic build and continuous integration for the scientific software. So this is just a list. I don't go into details. We sent also in the call for the forum a more complete list. And then since we had already Jenkins being used in the CSCS, we decided for a specific user, we decided to keep on using Jenkins for the continuous integration part. And so the first use case is to use Jenkins to do regular builds of our applications and also to automatically install everything. So we prepared EasyBuild configuration file for a new application. We put in a shared folder for accessible by Jenkins, and Jenkins will try this build during the night in no machines. So when we produce the new configuration file, we just test in one machine, and then the idea is just to give to Jenkins to run everything on all machines. So here we can see that all the EasyBuild apps are being run on Daint, on Pilatus and Santis, just for an example. And then next day we have the result and we can decide if we can install it on the other machines or not. So this is just an idea. We have already working. I prepared this a few days ago, and then we have only a few applications, and we are going to decide if we can extend that as a standard way of working for installing new applications. The second use case, it's more user-oriented. DCA++ is a user application, and it has dependencies that we don't usually, we don't have in all of our systems. For example, HDF5 with C++ interface, because it's made in C++, usually you have only HDF5 for C and Fortran. And so the idea here is to first use EasyBuild to provide the libraries, and then use Jenkins to run the regression and unit tests for two things: for test if the application is compiling and running correctly, and also to monitor the performance. So here we already implemented, together with the developer of DCA, some unit tests that run in parallel in our system. So Jenkins will go to PyTDora and PyTDaint and allocate and submit the job, run, retrieve the results, and have a log. So this is a very interesting integration, because every time the developer commits a new change in the code, Jenkins will fetch the code, run it, and give also the performance tests in our system. Of course, we need to decide how big should we run for how big should we dimension the job size for running so often. So we have just a minimal for the moment, just a small job but that is already interesting for the developer to check to monitor the performance of his applications. The last use case is the non-regression suite that is currently just it's based in Bash, so with some Bash scripts that are manually triggered when we have some upgrade, when we have some maintenance. And this is developed, it was developed by more than one people in CSCS, so it's people from systems, and there are some applications. And now, from our side, from the application, from the user engagement group, we would like to extend this suite for also building complex applications and monitoring the performance. Because right now, we don't know, some users often they ask us, they are saying that they have a slowdown, and then we don't have figures to say, and we just move this kind of ticket to the system people, and they say, okay, sometimes they have problem, but sometimes they have not. So here we would like to have some monitoring of the user experience, running some real applications that, for example, we will test the response time of the Slurm and the file system and the application. So if they have something weird or that is not usual, at least we have something to reply to the user, and also to detect problems maybe before the user in this case. So this is the workflow we prepared in the last days. So the idea here is to set up the EasyBuild environment and then create a new EasyConfig file, for example, using the Craig New toolchain. And once you finish the EasyConfig file, you build it with EasyBuild using the robot flag. And then if it works, you move this new configuration file to the common folder is this way, the folder that we are currently storing all of our easy config files. And then Jenkins, with the nightly builds, will try and deploy this application on the sandbox of all of our machines. And then, if it works, but on day 2, we check the build outputs, and then we can decide or not to move this new file to the automatic deployment. So one step is the testing in all of the systems. If it goes okay, we move to the automatic deployment. This way, we are sure that every time we install a new application, we have it available for everyone, which is a current problem right now. People are moving from one system to another, and then often they don't find the same set of libraries, and then we have to answer tickets and to work to find out that it's just a matter of version of libraries. So this way, we are sure that we have the same versions everywhere, and the user can use it as he wishes. So with this, I'll finish my presentation. If your group is interested in doing the same, more or less going in this direction, I would be glad to discuss. And now if you have questions about our setup. Yes, Pablo?
Are you using Elmod or other?
Sorry?
Are you using Elmod or other
Personally, I was using Elmod, but for the other user in the standard source, the environment, we are still using the standard one because we don't want we'd like to switch also, but it's too complicated. As I said, we have too many users, so we cannot just switch for all the users. We can switch internally for using easy build, but it's something that we are looking at. Yes?
How is the operating system provisioned on a new Cray node? Is there any alternatives provided by the system software?
For a new node, you mean if we are deploying a new Cray node? This folder is shared, actually. The apps folder is shared, so Nick could answer this question. But usually, from my point of view, I just install it on the shared folder. So
provisioning is done by the Cray package. So it's a separate entity. And as you point out, there's a separate directory on the global file system that's mounted out there.
any more questions?
You mentioned the non-regression tests and performance. Do you have something in mind already for integration with Jenkins? Or?
Yeah, we have it already for some small, like from testing BLAS, actually libsci, and then testing the output from some operation on matrices. And we'd like also to do some scalability testing. That is also an idea from someone in the US they also want to run some scalability tests to, from time to time, not use.
It's just some scripts or?
Yes, for the moment it's just some scripts, but we would like to enrich that with some applications, and we just have some calls to DGEM or something like that.
And do you get any, like you get for unit tests?
Yeah, we have failed or not depending on the time. That's what happens right now. If there's a threshold, if we go less, then it's okay. If it goes more, then it fails. So that's it.